like a new type of question in Chapter 7. I call a multi-revolution question. Sometimes in harder questions, if you give them a name, it makes them easier to remember the steps. If you Google multi-revolution questions, this is like, I made this up. I don't think anybody else uses these words. It's just something that I call it. And we'll see why I call it this, and it will help us remember the steps for a multi-revolution question. The first thing we're going to do is we're going to write out the steps. How do we solve for an equation when inside the function there's been horizontal stretch or compression? When there's something other than just an x. Up till now in Chapter 6, you always just had theta or just x inside. But now we're going to have like a 3x or a 2x. So the steps are going to look like this. First, we are going to rewrite the domain for 3x. And some of these steps won't make sense until we do some examples and see what this means for the work. And the reason I wrote 3x in quotation marks is because in our question we had a 3x. If it was a 2x in our question, we'd rewrite the domain for 2x. Step 2. Once you've rewritten the domain for 3x, well, now you are going to solve for 3x over the domain that you wrote. And finally, we'll solve for x. So multi-revolution questions, we'll rewrite the domain, we'll solve for whatever's inside over the new domain, and then we'll be able to solve for x. And when we see this example, so here's the example that I have. X is between 0 and 2 pi. And probably the easiest way to imagine this is if I got all of you to pick a number between 0 and 10. Some of you pick 3, some of you pick 1, somebody pick 9. And if I said, now that you've picked a number between 0 and 10, please multiply it by 3. Does it make sense that all of your new numbers are now between 0 and 30? Right? We started with numbers between 0 and 10. I told you to multiply by 3. Your new numbers are between 0 and 30. Well, the same thing is done here. We know that x is between 0 and 2 pi. Does it make sense that 3x's would be between 0 and 6 pi? Because we just multiplied it by 3. And what that means on your unit circle is if you go from 0 to 6 pi, that's once around the circle, twice around the circle, 3 times around the circle. So we're now going 3 times around the circle for 3x. And since we're going multiple times around the circle, this is why I call these multi-revolution questions. Because we're going around the circle more than once. So that's step 1. Step 1, rewrite the domain for 3x. Well, we were going from 0 to 2 pi. It got tripled because we want a 3x. It's now between 0 and 6 pi. Step 2, solve for 3x. Okay, so what all this means is you're solving this equation like normal. Is 0 on your pi plate as a y-coordinate? Yes. 0 happens here, 0, here, pi, and here at 2 pi, right? But that's only once around the circle. We need to solve for 3x. In other words, when is it equal to 0? But 3 times around. So the first time around will be 0, pi, and 2 pi. Second time around would be 3 pi and 4 pi. And the third time around would be 5 pi and 6 pi. But here we have to get mad at the textbook just a little bit. You see how the textbook didn't have a line with the 6 pi? So it means we can't include 6 pi. Even though it is a solution, but it's not in our domain. So step 2, we solve for 3x, just like you would solve for theta, or if it was just an x, but we solve for it over its new domain, which was 3 times around. Finally, step 3 says solve for x. Well, if you knew that 3 x's were each of these, just like when we picked our number between 0 and 10, and then I got you to multiply it by 3, I could perform some amazing mathematical magic. After you multiplied your number by 3, what did you get?
10. Wait, what was it?
What? First you picked a number between 0 and 10. Okay. Now you multiply by 3.
Oh,
and what did you get? You got 15. And now I'm going to perform some magic. Was your original number 5? How did I do that? Well, it's not that. It wasn't really magic, right? That's pretty bad mathematical magic. All I had to do was divide by 3 to figure out your original number. So all we have to do to figure out x here is take each of these answers and divide them by 3. So I take each of those answers, divide by 3, and now we've solved for x. And each of those answers for x are between 0 and 2 pi, which we wanted originally. Yeah.
Is it possible to get 10?
It would. You would have had to start with 3.33. And I would have figured that out too. That might be more mathematical magic if I figured that out, right? Okay, we're going to do another one just to get used to these steps. Okay, so the steps, first of all, we rewrite the domain for whatever's inside. We solve for that inside part over its domain. And finally, we just need to divide to get a value by itself. So here is our second example. Tan of 2 theta is equal to negative root 3. 0 is less than or equal to theta is less than or equal to 2 pi. Wherever you can find space, you can add this. So step 1, we rewrite the domain for 2 theta. So in this case, if 1 theta is between 0 and 2 pi, does it make sense that 2 thetas would be between 0 and 4 pi? And that means this is going not once, but twice around the circle for 2 theta. Then we solve for 2 theta. Is root 3 on your pi plate for 10? Yes. What family? Pi over 3. And then, because it's negative, you would have to write your pi over 3 families in quadrant 2 and quadrant 4. So you would start by saying 2 theta is 2 pi over 3 and 5 pi over 3, but that is only once around your circle. And for 2 theta, we have to go twice around the circle. So now I'm imagining over here, right, 2 pi over 3, and I have to go the next time around, I'm going to get coterminal with it. How do we find something coterminal? Does it make sense that you'd have to add 2 pi? But if I want to add something to a fraction, I need a common denominator. So 2 pi is the same as 6 pi over 3. And really, all you have to do is add 6 to your numerator. Same thing with the 5 pi over 3. I'm going to add 6 to my numerator there, and I get 2 answers of 8 pi over 3 and 11 pi over 3. Now we have 4 answers for 2 theta. The last thing we have to do is solve for theta. So we have to take each of these answers and divide them by 2. Mathematically, dividing by 2 is the same as multiplying by 1/2. And if you multiply something by half, all that's going to happen is your numerators are going to stay the same, and your denominators are going to get doubled. So I multiply 3 by 2, and I get all of my answers. 2 pi over 6, 5 pi over 6, 8 pi over 6, and 11 pi over 6. Yes, you could reduce some of those, but you don't have to. So in your questions at the back, you can circle number 10.